All right, in this video, we are going to review statistics. So title your notes, Statistics Review, in your table of contents, and at the top of your page, write Statistics Review. Hit pause to set that up, and when you're ready to move on, hit play. All right, first we need to review some terms. If you remember, our unit on statistics is a lot of vocabulary that you need to know. This should already be in your notes. If you want to jot it down again, you can, but it should already be in your notes so you don't have to copy it. Let's just refresh your memory. First, what is a population? It is the complete set of items being studied. And since it's not practical to be able to survey an entire population of people, we do a sample. A sample of a population is a part of the population. A sample is useful when you want to find out about a population, but you do not have the resources to study every member of the population. Each individual member in the sample is called a subject. All right, and then if you remember, our samples are either going to be representative or biased. Representative is when the number of subjects in the sample with the trait being studied is proportional to the number of members in the population with that trait. So with a representative sample, it is fair. It represents the population. You can set up a proportion with the numbers of the sample that would represent the numbers in the population. In a biased sample, the number of subjects is not proportional because it is a biased sample. Remember that bias means a tendency toward a particular perspective that is different from the overall perspective of the population. It is not a random sample if it's biased. So like here you see the population. Do you like sushi? We see it's about half and half, but then if we took just this group of 5 as our sample, that doesn't represent the population. If we took this group as our sample, that doesn't represent the population. You would want to pick a more random sample that would represent the population better. Okay, so a biased sample is not representative of the population. We can't use that to make predictions. So in these choices here, if we're studying the people in the United States who would spend at least 2 months of the year within 200 miles of the ocean, which of those would be the population? It would be everyone in the U.S. And then each of the samples, is it biased or not biased? Colorado, Iowa, and Kansas are these states in the middle. That would be biased towards saying no, they don't go to the ocean because they don't live anywhere close to the ocean. People in Florida, Hawaii, and Maine would be biased towards saying, yes, we go to the ocean because they live right there near the ocean. The representative sample would be picking 100 people from each state. That way you're getting all 50 states. You're getting a yes or a no, I go to the beach. That would be a fair representative sample. And remember that we can set up a proportion to make predictions about a population. So let's try this example together. Do this example with me in your notes. In a representative sample of 24 7th graders, there are 3 students with April birthdays. So I'm going to use the sample to set up the left side of my proportion. I have 3 April birthdays out of 24 people. So 3 have April birthdays out of 24 total people. And then they say, suppose there are 448 students in the 7th grade. That would be my total. And they want us to estimate how many students in the 7th grade have April birthdays. That's going to be n. And from there, we just solve our proportion. So we would cross multiply, and we would get 24n equals 448 times 3 would be 1,344. Then we just divide that by 24. Divide by 24. And we get we would predict about 56 of those students would have April birthdays. So that would be how we would use a representative sample to make a prediction about the population. Okay, now remember there are 3 different types of sampling methods. We have convenient sampling, systematic sampling, and simple random sampling. In convenient sampling, it is when we choose the members of the population that are convenient and available. So if I just surveyed the first 20 people I saw, that would be a convenient sample. Systematic sampling is when we pick some kind of an interval, like every 5th person, every 10th person, something like that, every nth member where n is a predetermined number. That is how we select our sample with a systematic sample. And then simple random sampling is when you have every member of the population has an equal chance of being chosen. Like you write everybody's name on a piece of paper and you draw names out of a hat, you give everybody a number and you randomly pick numbers, something like that where it's randomly being selected. Okay. So let's just go here and we can classify and then we'll move on. If we surveyed every 5th student who entered the music room, which would that be? That would be systematic because every 5th student. If we surveyed the students in the school whose names are picked out of a hat, that would be simple random. If we surveyed the students in the homeroom closest to the music room, that would be convenience. If we surveyed all of the students in the next band practice, that would also be convenience because they're all just right there. And then survey every 10th student, that would be systematic. So if you have a question about how to classify each different situation as either systematic, convenience, or simple random, you can hit pause and raise your hand and I'll come and explain it to you. All right, next, moving on to measures of center and measures of variability. This is more of our calculations in the statistics unit. The first kind of half of the unit is more knowing and applying vocabulary. So here, starting with measures of center, remember, to find the mean of a set of data, you add all the numbers up and then divide by however many numbers are in your data set. So here you see an example of that. You add all the numbers in your data set, and then you divide by how many numbers are in the data set to get your mean. To find the median, you want to place your numbers in order from least to greatest. Then if you have an odd number of data values, the median is the middle number. You'll just have one number in the middle. But if you have an even number of data values in your data set, you're going to cross, starting on the outside, cross them out to get to the middle, and you're going to get 2 numbers in the middle. When that happens, what you do is add them and divide by 2. So you find like the middle of those 2 middle numbers. Okay, and that will give us the median. Again, if you have questions about this, come see me and ask me and I can explain it further. All right, let's practice finding the mean. Hit pause and find the mean of this set of data. When you're ready to check your answer, hit play. So you would start by adding all the numbers up. I just punched them in the calculator and got 189. And then I counted how many numbers are in my data set. I got 9 numbers. And then you just divide. The sum divided by the number of numbers, and I got 21 was the mean. All right, next, remember the range. To find the range, and you may want to jot these little formulas down. I feel like this was what we had a little bit more trouble with, was the measures of variability than the measures of center. The range, you subtract biggest minus smallest, maximum value minus minimum value. So you take your data set, biggest minus smallest. That gives you the range. Next, quartiles. Quartiles divide the data set into 4 parts. The first thing you would do is find the median. The median is the second quartile. It's the middle number. From there, you treat that median as like a divider between the lower half of your data and the upper half of your data. And then to find the first quartile, or we called it Q1, you find the median of the lower half. Here it would be -1. To find the third quartile, or Q3 we called it, we find the median of the upper half of the data. Okay, last thing, interquartile range. We have already calculated Q3 and Q1 from what we did on the last slide. To find the interquartile range, we subtract Q3 minus Q1. Okay, and don't get this mixed up between the range and the interquartile range. They're different things. The range is the biggest minus smallest. The interquartile range is Q3 minus Q1. All right, I want us to practice finding all of these measures of variation, and this will be the last thing that we review, I think. So looking at this data set, let's start by finding the median. I see that I'm going to have to put my numbers in order from least to greatest. Let's quickly do that. So I'm going to start with 35, 80, and do this with me in your notebook. 100, 110, I see 2 120s, boom, boom, 170, and then 180. Okay? So I've put my data set in order from least to greatest. Now I'm ready to find the median. The median I'm going to cross out, starting on the outside. And with this data set, I have two numbers. So to find the median, I'm going to add those and divide by 2. So 110 plus 120 divided by 2. That would be 230 divided by 2, which equals 115. So the median is 115. Any questions at any point, just hit pause, raise your hand, and ask me. Now, when we have two numbers in the middle, I draw a line between them to separate the lower half and the upper half of my data. To find Q1, I'm going to find the median of the lower half of my data, so I'm going to cross out 35 and 110, and then I get two numbers in the middle here, so again, I add them. 100 plus 80 is 180 divided by 2, it's going to give me 90. That's Q1. 90 would be Q1. Alright, next let's do Q3. So I'm going to cross out 120 and 180, and I get two numbers in the middle again. So Q3, I add those and get 290 divided by 2, and that would give me 145 is Q3. Okay, 145 is Q3. Now, to find the interquartile range, remember I subtract Q3 minus Q1, 145 minus 90, and that's going to give me 55 as the IQR, the interquartile range. And then the range, I just subtract the biggest minus the smallest number in my data set. So 180 minus 35, that's going to give me 145. Alright, so finding any of these measures of variability, just raise your hand and ask me if you have a question. We could also find the mean if we wanted to here by adding them all up and dividing by, how many numbers do we have? 8. Add them up and divide by 8 would give us the mean. I didn't put that on here, but that would be how to do that. Okay. Oh yes, one more thing to review, box plots. This is very important. You will probably see a question about box plots on SC Ready. So all those numbers we just talked about are represented on the box plot. This part of the box plot is the minimum. The other end is the maximum. It's the biggest and the smallest numbers. Q1 is the left side of the box. Q3 is the right side of the box. And then the median is this line that goes down the middle. Between each of the two dots lies 25% of the data from the data set. Okay, so this is a way to represent those measures of variation. So here, from this box plot, if we were finding the range, I would just subtract, that looks like about what, 201 minus like 144 or something like that to get the range. To get the interquartile range, I would subtract the right side and the left side of the box. So make sure you know how to use each of those formulas with the box plot. Range, again, is biggest minus smallest. Interquartile range is Q3 minus Q1. So I would just subtract those numbers to get that. Okay. At this point, you should be ready to start on the statistics practice. If you have questions, please ask me. I'm happy to help you.